I'm Omale Jeff Jojo. You are welcome to today's class, matrices. Now, a matrix is a set of numbers arranged in rows and columns to form a rectangular array. For example, if you're having 3, 2, 1, 5, this is example of a matrix. 5, 6, 7, 8, 3, 2. Example of a matrix, you can have the one of 2, 3, 4, 5, 6, 7. These are examples of matrices, set of numbers arranged in rows and columns to form a rectangular array. This was first discovered in 19th century by James Sylvester, but it was his friend who started using it in linear systems, linear algebraic systems in 1850s by Atokali. So these matrices, they are very important in engineering, science, and the modern technology. So having known the examples of matrices, it simply means you can identify it anywhere. So there's what we call, we have to start from order of a matrix. Then from there, we know how to name a matrix. So what we have now is order. When you are talking of order of a matrix, what we're interested there is the numbers of rows and columns. The numbers of rows and columns. For example, let me start from row matrix. In row matrix, what we have is, let's say in this form, we'll say this is a row matrix. Why? Because it has one row. That is 1, 2, 3 is on a row. It has one row. Then how many columns do we have here if we are to name the order of this matrix? This is the row. Then this is the first column. This is the first column. The first column. The second column. The third column. This one row, 1 is standing on its own, 2 is standing on its own, 3 is standing on its own. So we have 3 columns and 1 row. So this one will now say it is order 1 by 3. We name the row first before the column. So we have 1 by what? 3. It is written like this, but if you want to pronounce it, it is called 1 by 3. Don't say 1 times 3. Please don't. So this is a row matrix. Then if you talk of column matrix, I'll say use 1 to 3 as an example. I have 1, 2, 3. Now in this case, you see that 1, 2, 3 is standing on its own, right? Now, then how many rows do we have here? This first row, second row, third row. The one in this way, horizontally, we call them row. The one standing, we call it column. And in matrix, we name the row first. So in this case, what we are having here is 3 by 1 matrix. So in pronunciation, you say 3 by 1. Do you understand? So the row is 3. We have 3 rows. 1 row, second row, third row. Then we have 1 column. So 3 by 1, because we name the row first. In this place, if you see it, we have 1 row. We start by the row 1. Then 1, 2, 3. We have 3 columns. So that's why it's 1 by 3. So this is all about how to name matrix. In matrix, you name the row first before the column. So we have 1 by 3, and this place the rows, we have 3 rows here, 3 by 1. So this first row matrix, second column matrix. Then we also have other matrices. We have other matrices like the null matrix. In a null matrix, all the elements are 0. Call it null matrix. Null. You can have 0, 0, 0, 0. You can have up to any number. This is a null matrix. Don't have identity matrix. In identity matrix, I can use 2 by 2. Identity matrix. In identity matrix, what you have, for example, is 1, 0, 0, 1. It simply means the numbers you have inside will only be 1. Call it identity. Then you have other matrices like the diagonal matrix. It's a matrix that all the leading diagonals are what? Numbers. All other ones are what? Zeros. So we'll call it a diagonal matrix. You can have it in this form, like 1, 0, 0, 0, 1, 0. I can use 2 so it not be identity, or 3, for example, 0, 0, 3. It simply means the leading, only the diagonals are what? Numbers. All other ones are 0. So let me go straight into today's work. There are other ones. If we start going on them, we'll get used to them. But we're talking of the order. So if I have an element of this form, let's say, let me say A equals 3, 2, 4, 1, 3, 6. So what will I name this? Now in this case, we have the first row, which is 3, 2, 4, 1, 3, 6, second row. So the what I'll do, since I have 2 rows, I'll say 2. Then I count the column 1, 2, 3. So this is 2 by 3 matrix. You first count the rows. You start naming a matrix from row. So I have 1 row, second row, I'll write the 2. That is 2 rows. Then 1, 3, 1 is 1 column. 2, 3 is another column. 4, 6 is another column. So I have 3 columns. So this matrix is 2 by 3 matrix. 2 by 3 matrix. So this is how to name the matrix with the order. Now let me go again to the major work of the day. That is addition and subtraction of matrices. Addition and subtraction of matrices. Addition and subtraction. So the matrix is already on the chart. So we have addition and subtraction of matrices. Now how do we add? What is the condition? You cannot just start adding matrices. What is the condition governing the addition and subtraction of matrices? Don't forget. The condition is, for me to add or subtract 2 matrices, they must have the same order. They must have the same order. A plus B. This place, I have 3, 2, 4, 5 plus 2, 7, 5, 3. So if I have it in this form, what I'll do, I'll check the order. But before you even bring to add, you have known, because 1, 2. I have 2 rows and 2 columns. So this 2 by 2, 1, 2, 1, 2. I have 2 rows and 2 columns. So this also 2 by 2. So the addition is possible. You must take note of this. The addition is what? Possible. So I now say 3. This I will add it. 3 plus this 3. The first element and the first row will add in the second of that matrix to the first element in the first row and first column. 3 plus 2, right? Then 2 plus 7. You shift, right? 2 plus 7. the same thing down. 4 plus 5 and 5 plus 3. 5 plus 3. So if you finish it like this, 3 plus 2 will be 5. 2 plus 7 is 9. 4 plus 5 is 9. 5 plus 3 is 8. So this is the answer, right? So this is the addition. For the addition to be possible, you must have the same order. And I've told you that order of a matrix is the numbers of rows and the numbers of columns. So the numbers of rows in the matrix A must be equal to the numbers of rows in the matrix B. The same thing with the columns to form matrix C in addition. So you can see that here. Now we can still use the same thing to subtract for you to see. See the same example, subtract for you to see. Now you can say, okay, subtract matrix A from matrix B. Now if you have such a thing, what to do is A minus B. You now say it's equal to 3, 2, 4, 5 in this way, minus the matrix B is 2, 7, 5, 3. Now the order must be the same. You can see we have 2, 2, 2, 2, the row, then the same column. So in this case, what to do is 3 minus 2. I'll go straight here. 3 minus 2 is 1. 2 minus 7 is minus 5. Minus 5, I have minus 1. 5 minus 3, I have 2. So this is the subtraction of matrix A from matrix B. I explain again. 3 minus 2 is 1. 2 minus 5 minus 7 is minus 5. 4 minus 5 is minus 1. And 5 minus 3 is 2. So this is the subtraction. Now let me show you another thing here. Under this subtraction, that's what you are supposed to know. That's what you are supposed to know. We'll still use these two as an example. We can use the 3, we can use 3 by 3, we can use any one, for example. Now, there's something you are supposed to know. A plus B is equal to B plus A. That is what they mean by what? Commutativity. That is, addition of matrices is what? Commutative. That is, A plus B is equal to B plus A. Now, if you have it in that form, let's assume that given that A is equals 2, 3, 4, 5, 6, 7, for example, as long as they have the same days, B, let me bring B here, B is equal to 5, 6, 7, 3, 2, 4 in this form. And they say I should show that A plus B equals B plus A plus B. This is what? This is 2, 3, 6, 4, 5, 7 plus 5, 6, 7, 3, 2, 4. Now this is A plus B. So what will I have? The addition says that I'll take the first element of A and the first element of B. So I have 2 plus 5, which is 7. 3 plus 6 is 9. 6 plus 7 is 13. Now come to this place. 4 plus 3 is 7. 5 plus 2 is 7. 7 plus 4 is 11. So this is what I have, the matrix say. And what I did to have this is A plus B. So I want to show also B plus A, since they say that A plus B is equal to B plus A. So let's do B plus A. This B plus A, which is equal to what? I'll bring the B 5, 6, 7, 3, 2, 4 plus 2, 3, 6, 4, 5, 7. So will it be equal to this? Now let's go with it and see. 5 plus 2 is 7. 6 plus 3 is 9. 7 plus 6 is 13. 3 plus 4 is 7. 2 plus 5 is 7. 4 plus 7 is 11. So you can see that the addition of matrix is commutative. A plus B is equal to B plus A. So it is also associative, but you are going to prove that yourself. It is also associative. That is, two matrices is also what? Associative. Associative. What they meant is A plus B plus C is the same thing as what? A plus B plus C. It is also associative. So go and prove this. Prove this and know. Use A equal to this and B equal to this to prove that it is associative. You first add this, add the C. So by adding this first and add this to this, you have the same answer. So addition is commutative. Addition is also associative. So we're on matrix, and I've shown you the answer we got from A plus B is this, and the answer we got from B plus A is also this. Multiplication is not commutative. When we get there, you will know whether it is associative if it is not commutative. Next class, we'll do multiplication of matrices and the transposition of it before we continue further. Thank you so much.